The Moon and the Earth rotate about their common center of mass, which is located about 4,700 kilometers from the center of the Earth. The distance from the center of the Earth to the center of the Moon is 3.84 times 10 to the 8 meters. Mass of the Moon is 7.35 times 10 to the 22 kilograms. Alright, let's sketch the situation before we start solving the problem. So what we are saying here is, if this is, say for example, the Earth, and its center is right at the geometric center here, and if the Moon is at certain distance from the Earth, let's sketch it right here, and its center is right here. Alright, so the distance from the center of the Earth to the Moon let's call it distance of the Moon to the Earth, the center of the Earth. Now, the common center is located within the Earth itself, and is a certain distance from the center of the Earth. Let's call this distance the distance from the center of the Earth to the common center. Let's represent it by EC. Distance from the center of the Earth to the common center, where the common center is right here. Alright, so what will the distance from the common center to the Moon be? Let's call that distance from the Moon to the common center. Alright, what are we given? We are given the distance from the center of the Earth to the common center. That's equal to 4,700 kilometers. This will be 4.7 times 10 to the power of 6 meters. That's converting kilometer to meters. And we know that the distance from the Moon to the center of the Earth is equal to 3.84 times 10 to the 8 meters. Therefore, the distance from the Moon to the common center will be equal to distance from the Moon to the center of the Earth minus distance of the Earth to the common center, from the center of the Earth to the common center. That will be equal to 3.84 times 10 to the power of 8 meters minus 4.7 times 10 to the power of 6 meters. That will be equal to 3.78 or 3.79 times 10 to the power of 8 meters. So now we know the distance from the common center to the moon. What else do we know? We know mass of the moon. Mass of the moon is 7.35 times 10 to the power of 22 kilograms. So what is A asking? Calculate the acceleration due to the moon's gravity at that point. So we are asked to find gravitational acceleration of the moon at the common point. And we know that the gravitational acceleration is given by the gravitational constant G, universal gravitational constant G, times mass of the moon divided by the square of the distance from the moon to the common center. Remember, universal gravitational constant at the table value is equal to 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. Alright, so let's plug in the numbers. 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. Alright, times the mass of the moon, which is given to be 7.35 times 10 to the power of 22 kilograms over the distance squared, which is 3.79 times 10 to the power of 8 meters squared. That yields 3.41 times 10 to the power of negative 5 meters per second squared. Alright, this is the gravitational acceleration due to the moon at the common center. B. Calculate the centripetal acceleration of the center of the Earth as it rotates about that point once each lunar month, about 27.3 days, and compare it with the acceleration found in part A. So we are given time taken to complete one cycle. So the Earth is moving with constant, the certain velocity around the common center, meaning this will be the trajectory of the center of the Earth around the common center. And how long does it take to complete one cycle? It takes 23.6 days. That's 23, or 27.3. And we need this time or period in seconds. To do that, we'll divide it by 1 day. and multiplied by 1 day equivalent hours, which is 24 hours. And we need to get rid of the hour, so we divide by 1 hour and multiplied by 1 hour equivalent seconds, which is 3,600 seconds. Okay, the day cancels out with day, the hour cancels out with hour, we are left with seconds. That's equal to 2.36 times 10 to the 6 seconds. Alright, so what will the velocity be? The velocity will be the circumference of the orbit divided by the period. So the velocity is going to be 2 pi distance from the center of the Earth to common center divided by the period. Plug in the numbers. Times that is 3.79 times 10 to the power of 8 meters. Divide that by the time taken to complete one cycle, which is 2.36 times 10 to the power of 6 seconds. That's equal to 12.52 meters per second. Okay, so now what we are asked to find is the centripetal acceleration of the center of the Earth as it rotates around its orbit, around the common center. So what is A sub c? And we know the centripetal acceleration is equal to v squared over r. That means the velocity which we calculated earlier, 12.52 meters per second squared divided by the distance from the center of the Earth to the common center, which is equal to 3.79 times 10 to the 8 meters. That yields 3.34 times 10 to the power of -5 meters per second squared. Alright, in these two numbers, centripetal acceleration of the center of the Earth when orbiting the common center and the gravitational acceleration due to the moon at that common center are very close, except for some rounding difference in between. And what does that tell us? The cause of the circular motion of the Earth around the common orbit is the gravitational force due to the moon. So the centripetal acceleration of the Earth when orbiting the common center of the Earth and the moon is equal to the gravitational acceleration due to the moon at that common center. So strictly speaking, the moon does not orbit the Earth. Instead, both the moon and the Earth orbit their common center, which happen to be within the Earth at about 4.7 times 10 to the 6 meters from the center of the